All right, get ready to dive deep into the world of AI. You've sent over a really interesting collection of articles on artificial intelligence and machine learning and how they're transforming, well, everything. And it seems like you're interested in going beyond the buzzwords. You want to understand the how and why behind it all, right?
Definitely a smart move because AI is rapidly becoming a part of so many facets of our lives.
Mhm.
It's not something that's way off in the future anymore.
Exactly. So, in this deep dive, we'll unpack all of it. We'll uncover what artificial intelligence actually asterisk, explore the different types of AI you might come across, and of course, we'll reveal why this technology is causing such a global buzz right now.
Sounds like a plan. Where should we begin?
Well, I think a good starting point is defining what artificial intelligence actually is. We hear about AI doing amazing, almost unbelievable things, but what's the core idea behind it?
At its heart, AI is all about creating computer systems that can perform tasks that usually need human intelligence.
Hmm.
Think problem solving, making decisions, and even understanding and using language, things we usually consider distinctly human.
And the articles you sent are full of real-world examples. It's not all just science fiction anymore, is it? For example, did you know that AI can now compose poems, instantly recognize images, predict stock market trends, and even come up with new designs for sandpaper?
It's incredible. And that sandpaper example that came from 3M, it really highlights how AI is being used in ways we'd never even considered before, often for everyday things. They're using AI to discover these tiny improvements that end up making a big difference.
I love that. It shows how AI is becoming seamlessly integrated into so many aspects of our lives, even if we don't realize it. Now, I did notice that your articles mention quite a few types of AI. Could you break down some of the key ones for us?
Absolutely. Image generation is a big one. Think AI creating images from scratch or based on descriptions you provide. Then there's text generation, where AI is basically learning to write like a human, crafting everything from a simple sentence to entire articles. It's pretty mind-blowing what it can do.
And we can't forget about speech recognition and generation. I mean, that's the technology that lets us talk to virtual assistants or have our phones transcribe our spoken words into text messages. Honestly, it feels like magic sometimes, but there's a lot happening behind the scenes, isn't there?
You're right, it seems like magic, but it's all thanks to some pretty sophisticated algorithms. And moving into even more cutting-edge territory, we have multimodal AI. This type combines different types of data, text, images, sound to get a more complete and nuanced understanding. It's a game changer, particularly in fields like autonomous vehicles that need to process loads of sensory data to navigate safely.
Wow, so many different types of AI already. And the field's evolving so rapidly, I feel like every day there's something new to learn about. But this is where it can get a little confusing, right? When we start throwing around terms like machine learning and deep learning, people often use these interchangeably with AI, but I'm guessing there are some key differences.
You're right, the terminology can get messy. It might be helpful to imagine three concentric circles. The largest circle is AI, the overall category. Inside that, we have machine learning. And then nestled within machine learning, we find deep learning, the most specialized of the three.
So AI is like the big umbrella, and then under that we have these more specific focused areas. Let's zoom in on machine learning for a moment. What's the fundamental concept at play there?
Basically, machine learning uses data to teach computers how to make predictions or decisions. It's similar to giving a computer a vast library of examples and letting it figure out the underlying rules for itself.
One of the sources you provided used a very simple math problem to illustrate this, and I thought it was brilliant. It made it so much easier to understand how an algorithm learns from those input-output pairs.
Exactly. It really highlights that machine learning isn't about painstakingly programming in every single rule. It's about letting the algorithm learn and adapt on its own based on the data we give it.
Which leads us to the machine learning workflow. It's not a one-and-done kind of process, right?
Not at all. It's more of a cycle. It starts with data preparation, which means cleaning and organizing all of that data, and then we move on to model training. This is where the algorithm really starts digging into that data and figuring things out.
And after the training's done, I'm guessing there's some kind of evaluation. Like we're checking in on our AI student to see how well they've learned,
Yeah,
right?
precisely. And based on that evaluation, we go through a process of optimization where we fine-tune the model to make it even more accurate, more powerful, and then the whole cycle can begin again. It's this iterative nature that allows machine learning models to keep learning and adapting.
So it's not just about building a static system, it's about creating something that can actually evolve and improve over time, kind of like how we learn as humans.
Exactly. Now, within machine learning, there are different approaches. The two main types are supervised learning and unsupervised learning. Imagine we want to train an AI to filter out spam emails. With supervised learning, we'd feed it tons of emails that are already labeled as spam or not spam. It's like having a teacher telling the AI the right answers.
That makes sense. So with unsupervised learning, we're taking away the teacher, right? The AI has to figure things out on its own.
Right. In unsupervised learning, the AI has to find the structure and patterns in the data all by itself. Think of it like giving the AI a huge basket of different fruits, but no labels. It's up to the AI to sort these fruits into groups based on similarities. It finds the shapes, colors, sizes without any prior guidance on how to categorize them.
It's like we're asking the AI to solve a puzzle without giving it the picture on the box. That's fascinating. Okay, so we've talked about AI and machine learning, but one of the terms I keep seeing in these articles is deep learning. What makes this type of machine learning so special? Why is everyone so excited about it?
Deep learning is where things get really interesting, where we start to see some of the most incredible breakthroughs. Basically, it takes inspiration from the structure of the human brain.
Okay, now you've got my attention. We're talking artificial brains. Tell me more about this.
Well, picture the intricate network of neurons in our brains, constantly processing and transmitting information. That's what deep learning tries to replicate. On a much simpler level, of course, with what are called artificial neural networks, or ANNs for short.
So we're basically creating a simplified version of the brain's wiring inside a computer. Is that a decent way to think about it?
A great way to think about it. And just like our brains learn and adapt through experience, these artificial neural networks learn from the data we feed them.
So I can imagine this network of artificial neurons all connected and firing away. But what does a deep network actually look like? Is it as mind-bogglingly complex as our brains?
It's not quite as complex as the human brain, thankfully, but it's still incredibly intricate. The basic structure of an ANN consists of three types of layers. You have an input layer, a bunch of hidden layers, and then an output layer.
So data goes in through the input layer, then something happens in these hidden layers that sounds kind of mysterious, and then we get our result at the other end. What exactly is going on in those hidden layers?
That's where the magic happens, right?
You got it. That's where the real magic happens. The hidden layers process information in this really amazing multi-layered way, kind of like how different parts of our brains are responsible for processing different aspects of information.
Okay, I think I get the general concept, but could you give us a real-world example to help us wrap our heads around it? Sure, let's say we want to teach an AI to recognize a cat in a picture. The input layer takes in the raw data of the image, basically, all those pixels. Then the hidden layers get to work, with each layer focusing on a different aspect of the image. One layer might be looking for edges, another might be analyzing shapes, and yet another might be identifying textures like fur.
So it's like each hidden layer is a specialist, picking out certain features and then passing the information on to the next layer.
Yes, exactly. And as these layers interact, the network as a whole starts to put all the pieces together, figures out, okay, this combination of edges, shapes, and textures, this must be a cat. Pretty cool, right?
That is really cool. So it's not just comparing the whole image to a database of cat photos. It's actually breaking it down and understanding the fundamental components of what makes a cat a cat.
Exactly. It's that multi-layered approach that makes deep learning so powerful. It allows AI to develop a much deeper understanding of the data than traditional methods could ever achieve.
That makes sense. So we've got these advantages with the multi-layered approach, but what are the real game changers? Why is everyone so excited about deep learning compared to other types of machine learning?
One of the biggest advantages is that deep learning can handle unstructured data, like text, images, and audio, much better than traditional machine learning. This opens up so many possibilities because so much of the data we generate in the real world is unstructured.
Right. Think about trying to analyze all the information in a video or on a social media feed. That's a massive amount of unstructured data.
Exactly. Another advantage is deep learning's uncanny ability to uncover hidden patterns and relationships in data, even things we might not have even thought to look for. It's like finding those aha moments that can lead to breakthroughs in medicine, business, you name it.
So it's not just processing, it's really extracting valuable insights. That's remarkable.
It really is. And if you remember us talking about unsupervised learning, well, deep learning really excels at this. It can learn without needing us to label everything in a data set, which is amazing because manually labeling massive data sets would be practically impossible.
It's like the more data we give it, the smarter it gets all on its own without us needing to hold its hand every step of the way. That's incredible.
It is pretty incredible. And another key point is its ability to adapt to new information. It's not static. It can continuously refine its understanding, which is essential in fields that are constantly changing and evolving, like, well, pretty much every field these days.
So we've got these amazing deep learning models all trained up and ready to go. But how do we actually take these sophisticated models from the lab and put them to work in the real world? That seems like a massive challenge in itself.
That's where MLOps comes in, which stands for machine learning operations. It's kind of like the bridge between building those powerful AI models we've been talking about and actually putting them to work in real-world applications.
So it's like the behind the scenes crew making sure everything runs smoothly.
Exactly. Imagine you've built this incredibly powerful race car engine. That's your deep learning model. Well, MLOps is the process of making sure that engine not only runs, but that it runs its absolute best in an actual race car, in a real race. It's about taking that raw power and turning it into real-world performance.
So taking something that looks great on paper and making it actually useful and impactful in the real world.
Precisely. And just like a well-run racing team has established procedures and best practices, MLOps relies on certain key principles to make sure everything works together seamlessly.
Okay, tell me more about those principles. What are some of the things that make MLOps so effective?
Well, it all starts with something called version control. Remember how we talked about the iterative nature of machine learning, how it's this constant cycle of training, refining, tweaking. Version control keeps track of every single change to the data, the code, the model itself.
So it's like having a detailed history of the AI's development, which I imagine is crucial when you're trying to understand why it makes certain decisions or how it's changed over time.
It's essential.
Yeah.
And it helps us avoid getting stuck with a model that's gone off track somewhere along the way. Now, another cornerstone of MLOps is automation. Basically, it streamlines the whole machine learning process by automating tasks like preparing the data, training the model, even deploying it for real-world use.
That makes sense. Less manual work, more AI doing what it does best, and probably much faster results too. I can see why that would be important.
Exactly. And automation plays a big role in the next principle, which is called continuous X. The X basically represents different stages in the AI lifecycle, things like continuous integration, continuous delivery, continuous training. It's all about this idea of constant testing, deploying, monitoring, and refining.
So it's like the AI equivalent of having a good fitness routine, right? Making sure it's always in tip-top shape.
That's a great way to put it. And then last but not least, we have model governance. It's not just about making sure the AI works well. It's about making sure it's used responsibly and ethically. So MLOps incorporates practices for data security, constantly checking for bias in the data or the model itself, and just generally addressing ethical considerations.
So building trust and transparency into the AI development process right from the start.
Exactly. You don't want to wait until there's a problem to start thinking about these things. Okay, we've covered a lot of ground here. AI, machine learning, deep learning, MLOps. But there's one more piece of the AI puzzle I want to make sure we talk about, and it's one that I always find particularly fascinating. Generative AI.
Oh yeah, generative AI. That's the one that really captures the imagination. Instead of just analyzing data, it can create completely new things, right? New ideas, new designs, things that never existed before.
You're exactly right. It's like AI is becoming an artist or an inventor.
The articles you sent are full of examples of generative AI. We're talking AI that can compose music, write different kinds of creative content, generate these amazingly realistic images just from a text prompt, even come up with designs for new products. It's mind-blowing.
It really is a whole new frontier. And what's so exciting is how it can break down those creative barriers that people often face. Imagine a world where anyone can express their ideas visually or musically, regardless of their artistic skills.
The possibilities are pretty much endless. But I have to ask, how does it actually work? What's happening behind the scenes to make all this creativity possible?
Well, most generative AI systems use really complex models, things like transformer networks, that have been trained on these massive, diverse data sets. And the key here is that they don't just memorize the data, they learn the patterns, the relationships, even the styles from the information they're given,
Yeah.
and then they use that knowledge to generate something completely new.
So it's like they've absorbed all of this creative material and then used it as inspiration to go off and create something original.
That's a great way to put it. Imagine a chef who's spent years tasting and experimenting with thousands of different ingredients, different cuisines from all over the world. They've developed this incredible mental library of flavors and techniques. Now imagine that chef using all that knowledge to invent completely new dishes, flavor combinations that no one has ever experienced before. That's kind of what's happening with generative AI. It's really quite amazing.
That's a great analogy. So we've talked about AI that can analyze data, make predictions, and now with generative AI, even create entirely new things. It's definitely inspiring, but I think you're right. It's important to talk about the implications of a technology this powerful as well.
I agree. The potential benefits are huge, from speeding up scientific discoveries to changing how we make art, design products, even how we communicate with each other. But it's also important to think about the ethical side to make sure we're using it responsibly.
Well said. The articles you shared were a fantastic starting point, but this field is constantly evolving. I feel like we've just scratched the surface today.
That's the beauty of it. It's an ongoing journey of discovery. I encourage everyone listening to keep exploring this fascinating world, dive into the latest research, stay curious about new applications, and never be afraid to ask questions. The future of AI is something that's being shaped right now, and we can all be a part of that.
That is a great point to end on. Thank you so much for joining us for this deep dive into the world of AI. It's been a fascinating conversation. And to everyone listening, keep learning, keep exploring, and we'll catch you next time.